Hi, my name is Rotem Ishai, and welcome to the presentation of the second assignment in my research inquiry as part of KIN 596. In this presentation, I will review and provide update on my research topic and questions. I will then review the methodology of two research articles that align with my research question, and I will conclude with a review of the proposed methodology for my research. To review my research question from the first assignment, my research question is what is the relationship between start positions, pacing performance indexes, and finish positions in XCO World Cup events? Now, start position is the athlete's call-up order number to the start grid. The finish position is the athlete race result as the final classification, their actual race result. And pacing performance indexes are pacing metrics that I've generated after reviewing XCO race pacing literature and highlighting three seemingly important factors. It's early race performance, middle race performance, and late race performance. Early and late race performances will be evaluated by positions gained or lost, as well as time as percent time behind leader, while middle race performance will be evaluated by percent time behind leader, as well as the variability of their middle race lap times. At this point of time, I'm not really contemplating on changing the primary research question, but rather looking into reducing the number of sub-questions, as you can see over here, and as I mentioned in my first assignment, that I need to narrow down the scope of my research, for the most part narrowing down the amount of sub-questions that I have. As you can see over here, there are so many sub-research questions over here that align to could be very different scopes, and I need to kind of pick and choose the ones that I want to continue with. I'm awaiting to discuss that with other people involved in the research, such as USA Cycling, performance manager, and the director of mountain biking, and understanding what would be the greatest impact and also what is feasible in terms of the tools that I have to move forward with those questions. So at this point, I don't know how my research will be quite defined, but I need to narrow down the scope, that's for sure. I chose to highlight two different research articles that align with my research question. And the first one right over here, study by McDermott and Hugh from 2012, is pretty close to the research question that I've asked. Their purpose was to examine the relationship between start and finish position in XCO World Cups over a 10-year period from 1997 to 2007. And to make comparisons with a model manipulating start position based on predicted athletic capabilities. They collected data from start and finish positions of all male and female race finishers in all the World Cup events between 1997 and 2007. The methodology was quantitative, obviously. There was no clear hypothesis statement that was really constructed within the study, but the authors approached this quantitative study examining whether or how the start structure and the lack of passing opportunities in those races actually kind of manipulated or corrupted the finish order. So the variables, the independent variable was start position, the dependent variable was finishing position. Some other variables and threats within this study methodology is that the start position, which is determined by a rider ranking, might not be the best fitting representative of their performance ability. And athletes do not perform in absolute consistency according to their theoretical ability. As we know as coaches as well, is that performance on a given day can fluctuate above or below their predicted ability. And also race characteristics, race environment, and race conditions can play a big factor in kind of changing the variability of athletes' performance on a given day. Some athletes do better in hot or cold conditions, on dry or muddy conditions, or altitude can play into effect, and those were not really considered within this research. And also all participants were categorized under either male or female category with no further subcategorization into age brackets. As we see today in XCO racing, there is a categorization for junior racers, under 23 racers, and elite racers. In terms of the procedures of this study, the race data collected from publicly available data, which is the same way I will collect my data. All this race data is publicly available. The start and finish positions were compared via Kendall's rank order correlation coefficient of both the race and module data. Simple linear regression line utilized to compare mean race data and module data. The results of this study came up with that, which is what is known in XCO Sport Professional, is that there is a significant correlation between start and finish position in both men's and women's races, and also that 57% of male athletes moved less than 15 position, and 62% of female athletes moved less than 10 positions throughout the whole race. So there's not a whole lot of movement of positions from start to finish. That's part of it is how the start grid is constructed, and the call up to the start grid, because if they're called up by ranking points, as well as the characteristics of an XCO racetrack, where there's only a very short start lap until they're going into very narrow, very technical parts of the XCO course, which does not allow for a lot of movement in positions because of the characteristics of the racetrack a couple minutes into the race already. Couple important things to explain the difference between this methodology and my proposed methodology, which I'll explain later on, would be the fact that they only looked at start position and finishing position. They did not look at any pacing metrics throughout the race. So they didn't look at lap times, which is also correlated with lap speeds, to see how those people who did change positions, when did that happen throughout the race, how they paced themselves. Did they have a fast start? Did they actually didn't move much at all early on the race and actually moved up towards the end of the race? So there's no understanding of the racers, kind of how they paced themselves for those who lost positions or gained positions. The second study I chose to review the methodology is by Pedro Vigario from 2021. The purpose of this study was to analyze the relationship between the position at the end of the first lap and the final classification in XCO competitions. The sample were of XCO elite male athletes from Portugal, and 5 races. It included 4 Portugal national championships between 2017 and 2020, and 1 Portuguese Cup in 2019. The study was a quantitative study. The hypothesis was, the H1 was that there is a correlation between the position at the end of first lap and the final classification in an XCO competition, and then the null hypothesis that there is no relationship. The variables were, the independent variable was 2 variables, was the position at the end of the first lap and the start position. The dependent variable was the final position. Some other variables and threats to this study methodology. First, we'll start with the fact that the sample size was very small. All those races had anywhere between 12 and 29 participants, so it's pretty small compared to the majority of XCO races out there, and especially World Cups that see attendance of about 100 racers. Also, we can assume that since those are races in Portugal, it is assumed that and national championships, which only Portuguese athletes are allowed to participate. So it's assumed that those samples consisted of obviously small, but also a very repeated cohort of athletes who raced many, many times together. So that might change the dynamics of the perception of what the athletes can or cannot do. How can they move positions or not move position because of their just kind of reoccurring rivalry together, racing so many times together for this small of a cohort. And also there is no description of the race courses, and we don't know how cohesive those race course characteristics are to traditional XCO, other XCO courses. And the collection of data, that was a correlation study from publicly available data. Pearson correlation coefficient was used to determine the correlation between the independent variables and the dependent variable. The results and conclusions that kind of came out from the study is that there is a high variation of position changes from the start position to the end of the first lap, and then there's a very low variability of position changes from the end of the first lap to final position, which means most of the position changes happen very early in the race, pretty much from the start gun to the end of the first lap, and then afterwards the positions don't really change as much. Which is once again kind of a known thing with XCO sport professionals, that a lot of the movement of position happening earlier in the race, and then it's kind of like people settle into their pace and just try to hold that pace to the end of the race. The good thing about this study compared to the previous one I presented is that there is a kind of a layer of analysis for pacing, because the author over here considered a start position and the position at the end of first lap and obviously the final position. So there is some kind of understanding of maybe pacing at the end of first lap, but it's not comprehensive enough. In order to really understand pacing, it's important to look at if we're only looking at time or lap times, then it's important to look at all the laps and not just one point during the race. More ideally would be to look at power output data, but that's not always that much available. So that's one good thing about the study, that it did add one more point to maybe give another layer of pacing understanding. But then on the other hand, it did not use all the lap times or all the lap positions. And then also it has a really kind of, it's hard to extract this information into other races in other countries and much bigger races, much bigger international races like World Cups, which is what I'm looking at. So this type of study, looking at all the laps and the relationship between all the laps and between early race, middle race, and late race kind of pacing and performance metrics is important. And doing this race not in one country with only a certain small cohort of athletes in one country, but rather looking at much bigger international, more representative races for my research question for looking at World Cups. So my suggested research methodologies include, first of all, looking at a very longitudinal perspective, so analyzing the data from all World Cup events between 2017 and 2023, which is the data that is publicly available as of right now, and then looking at all race categories. So there are 4 race categories in each World Cup, males and females, then under 23 and elite categories. And I think a big component of how my research methodology is different than the two other research articles that I've presented is that I will be integrating pacing benchmarks, which I've mentioned as the pacing performance indexes, which kind of puts an understanding of how each racer performed their performance early in the race, in the middle of the race, and late in the race. So adding those pacing benchmarks allows for kind of more in-depth and understanding how their race went and how they paced it and what happened during the race, and not just a simple look of where they started on the start grid and where they finished, understanding what happened throughout that race itself. And then in terms of the very specific statistics and methodologies that I will, more detailed methodologies that I will use, depending on the sub-questions that I will use. For an example, I could be analyzing for specific athlete development trends. So one thing that I was hoping to look at is picking the top performers in the World Cup, so looking at each and every single athlete that's been on an elite podium and looking back on that athlete's World Cup performances in years prior to their podium performance, and looking at their development of start positions, their finishing positions, and also their pacing, and if and how that relationship might have changed throughout their development years until they got on the podium for the first time. And then also looking at start positions and pacing matrices for performance benchmarks in World Cups. So a lot of times, athletes they set goals. If it's athletes or national governing bodies like national teams who select riders, they have certain goals that they have in mind for athletes that they select, and it could be for just finishing the whole distance, meaning not getting pulled by the 80% rule. Then finishing within the points, which is top 60 for males, top 40 for females, and then getting top 10 or getting podium spots or even winning the race, and looking what is the variation of the start position needed and pacing needed to get to those variety of performance benchmarks. Also, another analysis that I'm looking into doing is analyzing how those trends in start positions, pacing, and finish result might change from one course to another. With World Cups, it's pretty much the case that there are venues that repeat themselves year after year after year. I'd say out of maybe 7 World Cup races every year, maybe about 5 or 6 of them are repeated year after year after year, and the courses are very much similar one year to another, but then also conditions are not the same, so could be analyzing for race course or could be analyzed for conditions, as with mountain biking, especially most of the World Cups in Europe, could be the case where sometimes it could be hot and dry and sometimes it could be somewhat cold and very muddy, so it can go from very dry to very muddy. Those conditions are noted within the race analysis file, so I can look up for those. One important capacity that I'm looking into integrating to my research in order to not have that limitation of say some outlier laps or riders. Say, maybe a rider had a big mechanical that took him 5 minutes to fix that during a certain lap. That might represent his normal or his average performance, and those kind of outlier laps or riders, I'm hoping to have the ability to kind of note those, that when we see, say, an athlete maybe that should be on top 10 on the usual day, maybe had the big mechanical and they're finishing 33rd, I will be able to know which lap that happened on a specific rider and kind of pull those riders out and from their race data.